Okay, so this video is on the practice quiz, which is just like the quiz you're going to take. So make sure that you know how to do all of these problems on the practice quiz. So starting with number 1, we're simplifying. When we simplify, we want to kind of look at the numbers separately and then each different base. So number-wise, I have -2 times 5. That's -10. Now I'm going to look at all of my x's. If I have the same base, I keep the base and I add the exponents. So I have 3 plus 2 is 5, 5 plus 2 is 7, or 3 plus 2 is 5, 5 plus 7 is 12. And then my y's, I have 1y plus 1y plus 2y. So 1 plus 1 is 2, 2 plus 2 is 4. And then because these are not the same base, I can't do anything more, so I'm done. All right, number 3. First of all, I see that I have something to the 0 power, and anything to the 0 power is 1. And because this whole thing is in parentheses, this whole thing is 1. So I'm actually going to cross it off because it's 1. The next thing I'm going to do before I do any real simplifying is move this negative exponent down. Now, this 0 applied to everything because this was in parentheses. But this -4 only applies to the u because it's not in parentheses. So it's not applying to the 2, it's just for the u. So I'm going to move u to the bottom. When you move it, make sure you turn that negative positive and cross out the negative on the top. So now I'm going to do what I did before, which is look at my numbers. So my numbers are 2 and 2. So 2 times 2 is 4. And then on the top, I have an s to the 4th. On the bottom, I have a q squared and a u to the 4th. And because none of those bases are the same, there's no more simplifying, and I'm done. All right, number 2. Again, I'm looking at my number part. Number part and number part. So -25 divided by 5 is -5. And then I'm going to start moving some of my negatives here. I have x to the -6. I'm going to move that to the bottom and turn that into x to the +6. On the bottom, I have y to the -3. I'm going to move that to the top and make it +3. So now when I look, I have the same base of y. Keep the base and add the exponents. 5 plus 3 is 8. On the bottom, I have a base of x. I have a 3 and I have a 6. Keep the base, add the exponents. 3 plus 6 is 9. Number 4, before I do anything, I'm going to get rid of that negative exponent, and I'm going to get rid of it by just flipping my whole fraction. So remember, negative exponents, if it's on the top, it moves to the bottom. If it's on the bottom, it moves to the top. So for a fraction, the top of my fraction moves to the bottom, and the bottom moves to the top, or I just flip it. So 4b to the 5th over 3a squared, and now it's to the +3. And that means that everything is being raised to the 3rd power. So what I have is 4 to the 3rd, b to the 5th to the 3rd, 3 to the 3rd, a squared to the 3rd. So 4 to the 3rd is 4 times 4 times 4, or 64. Power to a power means I multiply, so 5 times 3 is 15. 3 to the 3rd is 27, and again, power to a power, I multiply, so 2 times 3 is 6. I can't simplify 64 over 27, and I can't do anything with those because they're different bases, and so I'm done. Okay, number 5 is just knowing how to rewrite it. So this is knowing that that is my denominator and that is my numerator. So this becomes 17 to the 3/2. And going the other way on this problem, it's knowing that this is what goes outside my radicals. So I've got a 5 here, and I can either write it like this in parentheses, squared, or I could have it be 7 squared in there. It really depends on what kind of problem you're doing. So either one of these works. These are both the same. So they both have the 5 here, and you can either put the squared outside in parentheses, or you can put it under the radical. All right, number 7. So I'm going to evaluate and simplify completely. So first I'm going to rewrite this. So that is my denominator. It goes here. and I have 16, and I'm going to use parentheses because it's easier. I don't want to have 16 to the third under my radical sign. That's a really big number. But this I can do. The fourth root of 16, well, 2 times 8, 2 times 4, 2 times 2. I have one group of 4. So the fourth root of 16 is 2, and then we still need to raise that to the third power. 2 times 2 times 2 is 8. And these kind of problems with just numbers you should be checking in your calculator. So after you do all this lovely work, you should be saying, okay, 16 to the alpha y equals 3 over 4 equals 8. All right, number 9. Again, I'm going to rewrite it. So I've got the fifth root of negative 32, and then this whole thing to the fourth power. And this does not mean I'm flipping anything. So the difference between number 9 and number 10. Number 10 is a negative exponent. I need to turn that exponent positive by flipping this fraction. This is not a negative exponent. 4/5 is positive. This is just a negative number. And that goes right here under the radical sign. And because it's an odd root, 5 is an odd number, it's an odd root, I actually can take an odd root of a negative number. So I know when I do this, if it's an odd root of a negative number, my answer is going to be negative. So I can actually just factor tree this like it's positive 32, just remembering that my answer is negative. So I've got 2 times 16, 2 times 8, 2 times 4, and 2 times 2. I'm looking for groups of 5, and I have this one group of 5 here. So the fifth root of negative 32 is negative 2. And again, that negative in my answer here is coming from the fact that that's negative. And now negative 2 to the fourth is negative 2 times negative 2 times negative 2 times negative 2. And that's going to be positive 16. Okay, number 8. Again, let's rewrite it first. The fourth root of 81, and then parentheses to the third power. Because I certainly don't want to do 81 to the third power without a calculator in here. That's a really big number. So let's look and see if I have any groups of 4. I have 3 times 27, 3 times 9, and 3 times 3. So I have one group of 4 3s. So the fourth root of 81 is 3. And I need to cube that. 3 times 3 times 3 is 27. And again, with these number ones, check this in your calculator. After you've done this work on your quiz, put in 81 to the alpha y equals 3 over 4, and there's my answer, 27. All right, last one, number 10 of this type. I want to get rid of that negative exponent. I'm going to flip my fraction. So 49 over 9, and once I flip it, I need to make sure I remember to write positive 3/2. And this means 49 to the 3/2 over 9 to the 3/2. You need to distribute it to both the numerator and the denominator. Well, this I can rewrite as the square root of 49 cubed. This I can write as the square root of 9 cubed. So the square root of 49 is 7. So I'm going to have 7 cubed. The square root of 9 is 3 over 3 cubed. And 7 cubed is 343. 3 cubed is 27, and that fraction also does not simplify. And if you want to know if a fraction simplifies, you can actually use alpha y equals and check it. So if I put in 343 over 27 and it simplifies, it will simplify it for me in my calculator. But if I see this, the same thing I put in, I know it doesn't simplify. So if you're bad at simplifying fractions, try alpha y equals on your calculator. All right, number 11. I am looking for groups of 5 because this is a fifth root. So 256 is an even number, so definitely divisible by 2. So I've got 2 times 128. 128 is even. 64 is even. 32 is even. 16 is even. 8 is even. And 4. So I'm looking for groups of 5. So 1, 2, 3, 4, 5. I have one group of 5 and I have 3 leftovers. Now, I can't make any groups of 5 if I only have 4 of something, but b to the 7th is 1, 2, 3, 4, 5, 6, 7. I can make one group of 5 with 2 leftovers, and of course c to the 5 is c, 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 and I can make one group of 5. So here's what's coming out. I have a 2 from here that's coming out, because I made one group of 5. I have a b that's coming out from my group of 5, and a c that's coming out. Here's what's staying in, and make sure you write that 5 in there. I have 3 2's, so I multiply them. 2 times 2 times 2 is 8. I have the 4 a's, because I couldn't make any groups of 5 with 4. I have 2 leftover b's here, and I don't have any c's. All right, number 12. To add or subtract, you have to have like terms, which means you need the same thing here, which I have. They're all cube roots, but you also need the same thing under the radical sign, and I don't have that right now, but they're not totally simplified. So we're going to simplify first and see what we get. So 24 is 2 times 12, 2 times 6, 2 times 3, and I'm looking for groups of 3. So I do have a group of 3 2's, and because there is already a negative 3 there, when I take out the 2, I need to multiply it by this negative 3 that's already there. So I have 2 times negative 3, which is negative 6, and my leftover is 3. For 16, if I start simplifying that, I have a group of 3 2's. And again, I already have a negative 3, so I need to multiply the 2 that I'm taking out by that negative 3 that's already there. So that also gives me negative 6, but this time I have a 2 left over. And then finally for 54, I have 2 times 27, 3 times 9, and 3 times 3. So I have a group of 3's that can come out, and a 2 that's staying inside. So now you think about these radicals as kind of like variables. It's kind of like x's and y's. They need to be the same. So I'm going to call this one x, the cube root of 3. Well, this is the cube root of 2. It's not the same. I'm going to call it y. And this one is the cube root of 2. I'm going to call it y. So when I'm trying to combine like terms here, I only have one of these. So I can't combine it with anything. I'm just going to rewrite it. Negative 6 cube root of 3. Now, these two I can combine. I have negative 6 of something and negative 3 of something. So how much do I have totally? Well, negative 6 and negative 3 is negative 9. And the something that I'm counting is the cube root of 2. That's my something. It's the same thing as like if I had negative 6y minus 3y, I'd have negative 9y. I'm counting y's. Here, I'm counting cube roots of 2. I have negative 6 cube roots of 2. I have negative 3 cube roots of 2. I get negative 9 cube roots of 2. The cube root of 2 doesn't change. That's what I'm counting. So don't change it. It doesn't become a 6th root or a 9th root. It doesn't become 4 on the inside. You're counting how many of these red circle things do I have. So don't change your radical. And then that's it. I can't combine this anymore. They're not like terms, and I'm done. All right, number 13, power to a power. It's fractions, but it's my same power to a power rule. I multiply. So when I multiply fractions, it's top times top, so 2 times 5, bottom times bottom, 5 times 3. And then if I have fractions, I always need to check and see if I can simplify, and this one I can. So I can divide both of these by 5. So I have 10 divided by 5 is 2, 15 divided by 5 is 3, and then that means this is the cube root of x squared. And on the last one, again, my same rule. I have same base, and I am dividing, which means I'm going to subtract. Well, to subtract fractions, you have to have a common denominator, which I don't have right now, right? I have 4 and I have 2. So I'm going to leave this alone, 3/4, but I'm going to change this 1/2 into something that's fourths. So if I want to change 1/2 into an equivalent fraction with a denominator of 4, if I multiply the bottom by 2 to get 4, I need to multiply the top by 2. So I multiplied that by 2, which means I need to multiply that, which tells me 2/4 is an equivalent fraction to 1/2. So I can say y to the 2/4. Now I look at this and I say, which one's bigger, 3/4 or 2/4? Well, 3/4 is bigger. That means it's going on the top. And it's bigger by how much? Well, it's bigger by 3/4 minus 2/4, which is 1/4. And then I can rewrite y to the 1/4 as the 4th root of y. So again, that is all the stuff on your quiz. Make sure you know how to do all of these problems. Your quiz is super similar to this.